So the majority of your body is made up of water. And that water we tend to divide into two main sections. Intracellular fluid, or ICF, is what you find inside the cells. That's what we call cytosol. And then you have extracellular fluid. Now, there are lots of things that make up extracellular fluid that we'll talk about in a moment, but things like blood plasma and interstitial fluid. The majority of this is intracellular fluid, but you have a fair amount of extracellular fluid too. And if you break down kind of all the stuff in a body, about 60% of it is water, about 40% are solids, but a third of the stuff in your body by weight is intracellular fluid, and then about 20% and change are interstitial fluid, blood plasma, other things, right? These are extracellular fluids. And then about 40% are solids, and solids are made up of organic things like proteins and inorganic things like calcium phosphate, which you find in bones. So this is a typical breakdown of the solid mass of your body, right? The biggest part is going to be proteins, followed by lipids. We all have a fair amount of fat in our body, followed by minerals. This will be primarily bones, right? Your calcium phosphate in your bones, followed by carbohydrates, and then various miscellaneous stuff. Now, for a lot of reasons, it's important that we maintain about the same amount of fluid in our body over time. And that means we have to balance water intake with water output. Well, what are some ways that we can bring water into the system? Well, one is through metabolic processes. We know that cellular respiration starts with sugar and oxygen and ends with CO2 and water. And that metabolic water isn't a huge amount, but it is substantial enough to matter. But the vast majority of our water comes in through the digestive tract, essentially drinking it. How do we lose fluids? Well, urination is a big one, right? We lose over half of our water through urination, but we also lose a fair amount through feces. There's a lot of water in your feces, and a lot through evaporation, and that could be evaporation through sweat. That could be evaporation through your lungs, right? So, the way they used to tell if a person was dead was they'd hold a mirror in front of their mouth, and if the mirror fogged up, they knew they were still breathing, right? So they were still alive. The mirror fogs up because you have water in your breath that comes out. So pro tip, if you are ever in the desert and you are stranded and you are trying to conserve water, keep your mouth shut because you lose a fair amount of water through your mouth. And that is a lesson that I learned from Captain Jean-Luc Picard. I'm not afraid to say it. All told, you want to balance the inputs with the outputs. And what are some things that are a little variable? Well, the water you consume and the water content of food is a little variable. And so if you drink a whole lot of liquid, you're going to have to balance that out in elimination. Well, you're probably just going to pee more, right? If you get less water, you're probably going to pee less. This is the big way that we can balance out our outputs with our inputs to keep things equivalent. We really absorb water in a couple of places. One is in the small intestines, and this is the majority, but we also have to reabsorb a lot of water in the colon, and that's because we're dumping a lot of water into the digestive tract along the way, right? And it's not only what we drink and then the water that's in our food, right? You eat a watermelon or a stalk of celery, there's a lot of water in that. But 1.5 liters of saliva a day, 1.5 liters of gastric juice, liter of bile, liter of pancreatic juice, couple liters of intestinal secretions, even 1/5 of a liter of mucus secretions in your colon, right? You need 1/5 of a liter of water for that. So it's really important that we're able to reabsorb all of that stuff, or most of it. And what we absorb into our circulatory system winds up in our extracellular fluid, right? So our blood plasma and then our interstitial fluid because of the blood plasma. But that ultimately is going to impact your intracellular fluid too because of osmosis. So your extracellular fluid and your intracellular fluid exchange water, and the direction, in which the water is flowing depends upon osmosis. So typically, if you look at your intracellular fluid and extracellular fluid, they have about the same concentration, right? And so they are isotonic with one another. But if you become dehydrated, so you're not drinking enough water, you're losing a lot of water via sweat because you've been working out, and you're not replacing it with drink, then all of a sudden you have less water. But you don't have less solutes, right? And so it's more concentrated over here. It's kind of like if you take a bucket of salt water or a cup of salt water and you let it sit out so that some of the water evaporates, right? All of a sudden you have half as much fluid. But you don't have half as much salt. You have the same amount. And so what's left is going to taste much saltier than what you had originally, right? Same with your blood plasma and interstitial fluid. If you lose a bunch of water but don't lose the solutes, this becomes more concentrated. Now all of a sudden this is not isotonic to your intracellular fluid. It is hypertonic. And so where's water going to want to flow? Well, it's going to want to flow out from your cells into your extracellular fluid, into your interstitial fluid, and then blood plasma. And that's not good for your intracellular volume, right? And then all of a sudden this becomes more concentrated, more ions, and that can cause a bunch of issues that we'll talk about later. And so how do we fix that? Well, you have to then, that's the same thing I just showed you, sorry. You have to drink more water, right? And that makes this more dilute, right? Brings you back up to here, and this becomes hypotonic, and water flows back into your intracellular fluid. In the same way that we have to balance water inputs with water outputs, we also have to balance our mineral inputs with our mineral outputs. So things like ions, so think sodium, potassium, calcium, phosphorus, phosphate, things like that. So generally we have to balance absorption, what we eat and absorb through the intestines, with excretion via the kidneys into our urine, and also we lose some of the stuff in sweat glands, right? And this is what it kind of looks like, right? This is our input, and this is our output. But we also have reserves, especially for things like calcium and phosphate. We have reserves in your bones. So if you are low on blood calcium, well, you just secrete some parathyroid hormone and you stimulate osteoclasts to break down more bone, and you dump some extra calcium in the blood. If you have been taking in a lot of calcium, well, then you stimulate some calcitonin and you stimulate some osteoblasts, and you send that calcium into the bone for later. So let's talk about a few specific minerals that are important to your body. One hugely important one is sodium. And sodium is important partially because it regulates your fluid volume, right? We've talked about that when we talked about blood pressure. So we have to balance more or less sodium gains with sodium losses. And small changes in sodium can lead to small changes in blood volume, and that's not a big deal. Big changes you're going to have to deal with in more global reactions. So let's say you just ate a bunch of French fries, big consumption of salt, right? Well, that's going to make you think that you're dehydrated, right? Because the way that your body realizes you're dehydrated is that you have essentially a really, really concentrated salty extracellular fluid, right? Because, wrong one. This is what I'm looking for. Because typically if you lose fluid, that's how you end up with a high concentration of sodium. So eat a lot of sodium, your body thinks that this is happening. Once you have stimulated those osmoreceptors in your hypothalamus, the hypothalamus is going to cause you to release antidiuretic hormone because you're dehydrated, right? And so you want to stimulate thirst and promote the reabsorption of fluid in the kidneys. And you reabsorb more fluid, and your extracellular fluid is back to normal concentration, and you are in good shape. The opposite happens if your sodium levels are very low. That makes your osmoreceptors in your hypothalamus think that you have a little bit too much water, and so you're going to stop secreting ADH, and you're going to pee more to get rid of that extra water, and that will balance out the ratio of water to sodium in your extracellular fluid. Now, those changes are all fine and good if what we're talking about is a very small change in fluid. But if those sodium imbalances cause you to have much bigger changes in fluid, then that can impact your blood pressure, right? As volume increases, right, you have increased blood pressure, and that's going to cause you to stimulate mechanisms to kick into gear that will lower your blood pressure. Or similarly, if your blood volume is very decreased, you will stimulate mechanisms to increase your blood pressure. So, for instance, imagine if you have increased blood volume and blood pressure. Well, how do you deal with that? You secrete natriuretic peptides, both atrial natriuretic peptide and brain natriuretic peptide. That is going to do the opposite of aldosterone, right? It gets rid of sodium. So we lose sodium in the urine, water follows the sodium, it also inhibits thirst and all these other things. And that decreases our blood volume, right? And decreased blood volume means decreased blood pressure, and hey, we're back to normal. If it's the opposite, and our blood volume has been decreased, right? Well, then our kidneys are going to notice, and they're going to secrete renin from the juxtamedullary apparatus, if you recall. And that renin is going to cause us to secrete angiotensin, which tenses those blood vessels, which cranks up blood pressure. It's also going to increase aldosterone release, and aldosterone causes us to retain sodium, and water follows the sodium, so we have higher blood volume. Higher blood volume means higher blood pressure, and we're back to normal. It's also going to increase ADH release, right? These things are also going to make us more thirsty, so that we drink more water, again, to increase blood volume, to increase blood pressure. So you can see how these things are all related to what we've talked about in the past with the cardiovascular system. If you have too much sodium in your body, we call that hypernatremia. Natremia, Na, is the symbol for sodium, right? So hypernatremia is too much sodium. If you have too little sodium, we call it hyponatremia. And this hyper and hypo are going to come up several times, right, in this chapter. The most common cause of hypernatremia is just going to be dehydration, right? You've been losing too much water and you haven't been replacing it. And so because you've lost water and you haven't lost sodium, the sodium concentration is higher, right? So hypernatremia. The most common cause of hyponatremia is either inadequate salt intake, right, or overhydration. And you can overhydrate. Now, very few people do this, but you can overhydrate, and that can cause hyponatremia. Another important mineral that we have to balance is potassium. And we have to balance essentially our absorption of potassium through our digestive epithelium and the loss of potassium in the urine. And unlike sodium, which has its highest concentration in extracellular fluid, like your blood plasma and your interstitial fluid, potassium is highest in the intracellular fluid. And this is because of those sodium-potassium pumps. The same thing that's pumping sodium out of the cell is pumping potassium into the cell. So you tend to have a lot of potassium in, a lot of sodium out. So once you absorb potassium into your body, it pretty quickly, at least most of it, gets pumped inside your cells. Excess gets moved outside the blood into your urine via the kidney. And the primary factor in maintaining an appropriate concentration of potassium are the kidneys. And because you tend to have a relatively consistent intake of potassium. And what causes us to get rid of potassium is aldosterone. And we think of aldosterone as the salt retaining hormone, right? It keeps us to maintain sodium, right? But when it maintains sodium, retains sodium, it gets rid of potassium, because the way that we move that sodium is with the sodium-potassium pump. So the sodium that we move back into the blood is causing us to get rid of potassium into the urine. Now, an important thing to note is that when you have acidic blood, sometimes hydrogen ions can get pumped out those sodium-potassium pumps instead of potassium, and that'll become important when we talk about acidosis. This occurs in the distal convoluted tubule and the collecting duct. Aldosterone causes us to retain sodium and put potassium in the urine, and again, under levels of under acidosis, acidic pH in your blood plasma, you can swap hydrogen ions for that potassium, pump them out into your collecting ducts, and retain that sodium still. Having too much or too little potassium in your extracellular fluid, and therefore your intracellular fluid, can be a huge, huge deal in terms of your health. How does it impact your health? Well, we will talk about it in the next video.